بسم الله الرحمن الرحيم. We'll start this section 4.1 extreme and uninterval. So first we define what they mean by absolute minimum and absolute maximum. Let f be defined in an interval containing c. So we say f of c is the absolute minimum of f. Look at this, f of c, the y value is the absolute minimum of f. When f of c is less than or equal f of x for all x in the interval. So f of c will be the smallest value in all, over all the interval. And we say f of c is the maximum if f of c greater than or equal f of x for all x in I. And we call this absolute maximum, absolute minimum, and sometimes we call it global minimum or global maximum. Okay. So the idea, the absolute minimum will be the smallest value over the full interval, and the absolute maximum will be the highest value or the maximum value over the full interval, or the largest value over the full interval. And we are looking about the y value, f of c, not c. So, and we say the absolute maximum happens at x equals c. But what is the absolute maximum or what's the absolute minimum will be the y value. Okay, let me consider this function with different domains. If we took x squared from minus infinity to infinity, yeah, we notice we have here absolute minimum. So absolute minimum is 0 at x equals 0. Is there an absolute maximum? No, because the function is going to infinity in both directions, since I'm taking the full interval, minus infinity to infinity. So no absolute maximum. Okay, let me take the second case. I have this closed interval between 0 to 2. Between 0 to 2. This is, yeah, so we have this value will be the smallest one, and this will be the largest, which is 2 and 4. So what is the absolute maximum? It's 4 at x equal 2. So the y value, which is 4 at x equal 2. And what is the absolute minimum? It will be 0 at x equals 0. Do we have? Yes, because this is defined, everything is okay. Now, the third case, I have it open from at 0, but closed at 2. So this is open. So do we have absolute minimum here? No, no absolute minimum. We cannot say a point, a value, which is defined in the function, where this value is the smallest one, because this is an open interval. Absolute maximum, yes, we have absolute maximum, which is 4 at x equal 2, since this is closed. The last one, I have open interval 0 and 2. Open interval 0 and 2. Here, no absolute maximum, no absolute minimum. So this is open and this is open. Okay. Also, we need to define what's called local maximum and local minimum. Now we need to be careful. Local maximum. It means that we want to find the maximum locally. Also, we call it the relative maximum. So we want to check the maximum locally. So we say if f of c greater than or equal f of x, the same idea, but when x is near c, means in some open interval containing c. Okay, now let me look at this graph. First, let me check the absolute maximum, or let me say the local minimum will be the same idea when x is near c. Okay, now look at this graph. Where is the absolute maximum? This will be the absolute maximum, which is d, which is f of d is the absolute maximum at x equal d. Absolute minimum will be this one. So f of a is the absolute minimum at x equal a. Okay. So this is the absolute maximum, absolute minimum. Now let me consider the local maximum and local minimum. Local maximum, if we think about B, if we take an open interval containing B, then this will be local maximum. So f of B is the local maximum at x equal B. Okay. Now, what will happen at D? Yes, D will be an absolute maximum and a local maximum. Also has a local maximum at D, which is f of D. Which is f of D. So f of D is an absolute maximum and a local maximum. Since if we took an open interval containing D, will be the maximum. Now let me deal with the minimum. Let me do it backward. So I have E is a minimum because if we take an open interval containing E, f of E is also a local minimum, which is f of E, will be the local minimum. Now, C is same thing. If I take, if I take an open interval containing C, this will be a local minimum. So if at x equals C. Now, what about f of A? F of A, can I take an open interval containing A? No, because I can do it from this side, but not from this side. So we don't have a local minimum at x equal A. No local minimum at x equal A. It's an absolute minimum, yes, f of A, but we don't have a local minimum at x equal A because we cannot have an open interval containing A. In general, near C means that for all x in the open interval containing C. That means the endpoint cannot be local maximum nor local minimum. Let me check this graph. Also have a note, every absolute is local except the endpoint. But the converse is not true. So if you have local, it doesn't mean it's absolute. And for example, in this example, this is local, but not absolute. But every absolute is local. Okay, so let me check this graph. Let me do absolute minimum. What will be the absolute minimum? The smallest is this one, which is 1, 2, 3, 4. And what is the value? So it's 1 at x equal 4. Absolute maximum. This is open, so no absolute maximum. Done with the absolute. Now, local minimum. Check where we have local minimum. This one cannot be local minimum because this is an endpoint. This one is a local minimum. If we take an open interval, so this will be local minimum. So I have local minimum 1 at x equal 4. What else? Here, if I took an open interval, we took open interval here, what will happen? This will be the smallest. Over this interval, this point will be the smallest point, or the lowest point. So we have absolute local minimum 2 at, it's 2 at x equal 2, at x equal 2. Okay, now let me consider the absolute maximum, the local maximum. I have this, it's a local maximum. Take an open interval, this will be the highest point. So I have local maximum, what is it? 1, 2, 3, 4 at x equal 1, 2, 3, at x equal 3. What else? Here also the same thing. I have a local maximum. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3. So I have a local maximum 3 at x equals 6. Okay. More examples. Let me take f of x equal cosine x. Yeah. So if you think about cosine x, doing it like this. No, this is sine. The same idea. Just doing it like this. And continue. So we have an absolute maximum. How many absolute maximum we have? Only one, which is one at many values, at infinitely many points. Infinitely many x values. But how many absolute maximum? Only one. Absolute minimum minus one, the same thing at infinitely many x values. Local maximum is one, also at different values. On the same thing for the local minimum. Let me take this one, x squared. Actually, we did it. So we did this one. X cubed. Let me do it x cubed. This is the graph over the x cubed. So for sure, no absolute maximum. Goes to infinity. Goes to minus infinity. No absolute minimum. Okay. Now, locally, if you took an open interval containing zero, because I'm expecting the zero, we take an open interval containing zero, so we cannot say in f of zero is the lowest point because I have a negative side, and we cannot say f of zero is the highest point because you have a positive side. So also no local minimum and no local maximum. Okay. Now, if we think about this relative or local maximum or local minimum, we notice one thing. Notice it will happen when I have horizontal tangent line. When I have f prime is equal to 0. F prime at x equals 0. This is the same thing here. This is the relative maximum. So I have f prime at this point is equal to 0. And the same thing here. I have a horizontal tangent line. So f prime at this point is equal to 0. Not only that, in this case, in the absolute value of x case, f prime at 0 does not exist, but still this will be the relative. This will be a relative minimum. So it means this this case of having relative maximum or relative minimum, it happens when f prime is equal to 0 or f prime does not exist. So we call this, so we define what's called critical number. What's the critical number? I need f prime is equal to 0. F prime is equal to 0, or if f is not differentiable. But be careful. Also, I want f to be defined at C. That means C in the domain of f. So I have three conditions. 1, C in the domain of f. 2, f prime is equal to 0, or 3, f is not differentiable. Not only that, also we have this theorem. It says what? If f has a relative minimum or a relative maximum at x equals C, if I have a relative minimum or relative maximum at x equals C, what will happen? Then this C must be a critical number, which is what we show you. Either f prime will be 0 or f prime does not exist, which means it's the critical number thing. And for sure, it will be defined since it has a relative minimum. So it's part of the function. Okay, let me do these questions. Find the critical numbers. Okay, number 1. What I will do, I need to check this. So I need f prime. F prime exists equal to 0, if or not exist, or doesn't, or if it's differentiable, or if prime at C equals 0, or if it's not differentiable at C. Let me check f prime. What will be f prime? That will be x cubed minus 3x, which is x times x squared minus 3. So this is f prime. Okay, what's the domain of F? Domain of F or real numbers. This is divide everywhere. Okay. Now, F prime equals 0. I'm getting what? X equals 0 or X equal plus or minus the square root of 3. Are they in the domain of F? Yes. Yes, it's the domain of F or real numbers. Now, I check F prime does not exist. Nothing, because this is always exist. Actually, F prime always exist. So we have nothing here. So what are the critical numbers? X equals 0, X equals square root of 3, X equal minus the square root of 3. Second case, F prime of X, F prime of X will be what? 12x cubed minus 6x to the power 5. Okay, I can take 6x cubed common factor. So I have 2 minus x squared. Yeah, so 12x cubed minus 6x to the power 5. Correct. Now, what's the domain of F? Or real numbers. Okay, F prime of X equals 0. I'm getting X equals 0 or X equal, yeah, actually it's the same, plus or minus square root of 2. F prime does not exist. Impossible. So what are the critical numbers? X equals 0. This is in the domain. This is in the domain because the domain are real numbers. Huh? X equals square root of 2. X equal minus square root of 2. Okay, let me take the third case. What is F prime? F prime will be 10 over 3 x to the power minus 1 over 3 plus 5 over 3 x to the power 2 over 3. Okay, now we took common factors. 5 over 3 x to the power or minus 1 over 3 times, this is what? This is 2, it's plus, huh? I didn't change the sign, okay. 2 plus x, check. Multiply this by this, I have 10 over 3 x to the power minus 1 over 3. By this, I have 5 over 3 x to the power 1 minus 1 over 3, which is 2 over 3. Okay. Now, what is the domain of F? Orion numbers also. The domain of Orion number. I have no restriction in X, since it's cubic root. Okay. Now, F prime equals 0. Oh, by the way, let me rewrite F prime in a nicer way. Easy to conclude. So that will be 5, 2 plus x over 3, x to the power 1 over 3, or cubic root of x. Okay. So F prime is equal to 0, implies this is equal to 0, so x equal minus 2. In the domain of F, yes. Actually, what is the domain of F? The domain of F are real numbers, huh? So we have no restriction. Now, F prime does not exist. That will happen if x equal 0. Is it in the domain of F? Yes. So what are the critical numbers? X equal minus 2 and x equal 0. These are the two critical numbers. Yeah. Let me do more problems. Okay. I have number 4. The same thing. We'll do F prime. It will be what? 1 minus 1 over 2 root x. Yeah. What's the domain of F? Be careful. Domain of F is, I need x to be positive, so the domain of F from 0 to infinity. Close with the 0. Okay. And let me rewrite F prime in this way. It will be 2 root x minus 1 over 2 root x. Okay. So F prime equals 0. That means 2 root x minus 1 equal to 0. So I have 2 root x is equal to 1. Or let me say root x equal 1 over 2. Yeah, let me do it right away. So that means x equal 1 over 4. Is it in the domain of F? Yes, it's in the domain of F. Okay. Now, F prime does not exist. When is that? if x equal 0. Is it in the domain of f? Yes, it's in the domain of f. So what are the critical numbers? X equals 0, or let me say x equal 1/4, no difference, and x equal 0. Yeah. Since I have a space here, let me do it here. Number 5. X ln x. Is it? Yeah. What's the domain of f? From 0 to infinity. I need x to be positive. Okay. F prime will be what? I have product rule. It will be ln x plus x times 1/x. In other words, this is 1 plus ln x. F prime equals 0. So you have ln x. Let me do it in steps. 1 plus ln x equals 0. So you have ln x equals -1. Yeah, the argument of ln cannot be negative, but ln can be negative. Because if you think about the graph of ln, yeah, there is a portion where ln is negative. Huh? Okay. But the argument, which is x, this should be positive. Okay. Now take a of both sides. We get what that x equal a is -1, which is 1/a. Is it in the domain of f? Yes, it's in the domain of f. Now, if we say f of the f prime does not exist, yeah, we have nothing because it does not exist if x is non-positive, but it's not in the domain, so we just ignore it. So what are the critical numbers? X equal 1/a. X will be 1/a. Yeah. There was a question here. Sorry. Yeah. So let me do this number here. No. There. Let me do it here. So what is the function? So do I have space? Now I understand. X to the power 3/5 times 4 minus x. We'll do the same. What is the domain of f? Or real numbers. We have no problems because this is fifth root. So everything is defined. Now, what is f prime? What is f prime? F prime will be product of two functions. Now the things becomes complicated. 3/5 x is -2/3 times 4 minus x. Derivative of this is minus, so I have minus x to the power 3/5. This is 3/5 minus 1 minus 2/5. Okay. Now take a common factors, which is x to the power -2/5. What's the remaining? 3/5 times 4 minus x minus x. Check, multiply 3/5 x is -2/5 times 4 minus x. And this is x1 minus 2/5 is 3/5. And the derivative is correct. Yeah. -1 minus the first one. Okay. Now, this one I can rewrite it. Yeah, I can have 5 here. So I have in the denominator 5 x to the power 2/5. Okay. In the numerator, I have what? 12 minus 3x minus 5x. In other words, I have 12 minus 8x. Yeah, this is very clear, 8x. So let me take 4 as a common factor. Yeah, to make it easier. So I have what? 3 minus 2x, which is 12 minus 8x, which is this over 5x to the power 2/5. Okay. Now, f prime equals 0. Very clear, x equal 3/2. Belongs in the domain? Yes. F prime does not exist. I have x equal 0, which is belongs in the domain of f. So what are the critical numbers? What are the critical numbers? X equal 3/2 and x equal 0. Okay. Yeah, so we did this. Now I go back to this x cubed. Why? Because if you notice, this x cubed Now, if I want to check the critical numbers, so let's say, what's the domain of f? Domain of f, or real numbers. Domain of f, or real numbers. Now, f prime of x cubed, it will be 3x squared. So, I have f prime equals 0. So, I have x equals 0. Belongs to the domain of f. F prime does not exist, yeah, impossible. Okay. So, I have the critical number, x equals 0. Be careful. From x cubed, from the graph of x cubed, we say f has neither local minimum nor local maximum. Will that conflict this theorem? No. But this theorem is saying what? If f has a relative minimum and maximum, then c is a critical number. The other way, the converse of this is not true. It doesn't mean if I have a critical number, I should have relative minimum or relative maximum. No. And this is a clear example where I have a critical number, but still f has neither local maximum nor local minimum. Okay, this is another example. Now, what's the domain of f? Or real number. Okay, this belongs to the domain of f. Yeah, 0 belongs to that. Yeah, have it here. No. Okay. But I know that what is f prime? Yeah. F prime does not exist at x equals 0 since we have a corner. So critical number, and this belongs to the domain of f. Critical number is x equals 0. So the critical number will not come only from f prime equals 0. Sometimes it comes from when f prime does not exist. And this is an example. Okay, let me go to the old exams questions. Mainly the old exams questions about critical numbers or critical points. Huh? Yeah. And sometimes they relate. Sometimes they ask about this this theorem. If he said it has a relative minimum, relative maximum, then for sure there is a critical number there. Okay. So let us do the calculation. The sum of our critical points of this. Yeah, this is now a quotient rule and has also the chain rule. Okay. So what's the domain of f? This is my first step. I have 2x plus 1 positive. It means x should be greater than minus half. Okay. Now f prime. Be careful with f prime. I have derivative of the numerator, 2x, times the denominator, which is 2x plus 1 to the power half, minus the numerator. Derivative of this, which is this one, that will be half, 2x plus 1 to the power minus half, derivative of this, which is 2, all over square of this, which is 2x plus 1. Okay. Now let me try to simplify the numerator. I have 2x plus 1 to the power half. Here I have what? This 2 cancelled with this 2. And I have what? Minus x squared plus 1, 2x plus 1 to the power minus half. All of this over 2x plus 1. Now I can take 2x plus 1 to the power minus half as a common factor in the numerator. So I have here 2x times 2x plus 1. Multiply, I'm getting this, minus x squared plus 1. All over 2x plus 1. Okay. So I have what? I have 4x squared minus x squared. That will be 3x squared plus 2x minus 1 over 2x plus 1 to the power 3 over 2. Okay. Now, f prime equals 0. Don't forget the domain. Huh? Put the domain in your mind. Okay. That means what? 3x squared plus 2x minus 1 equals 0. Can I factor this? This is 3x. This is x. Yeah, this is -1 and this is +1. Am I right? 3x squared minus x plus 3x, 2x minus 1 times 1. Yes. So I have x equal 1 over 3 or x equal -1. This is belongs to the domain of f. Since agreed with this. This one, no, does not belong to the domain of f. Oops. Yeah. When f prime does not exist, if x equal -half, and this does not belong to the domain of f. To the domain of f, I need x to be strictly greater than -half. So what are the critical numbers? I have only one, which is this one only. This does not belong, this does not belong, which is x equal 1 over 3. Yeah, which is this one. The critical number of this function, x squared ln x. Let me do the calculation. What's the domain of f? X should be positive. F prime of x. Derivative of the first, 2x ln x plus x squared times 1 over x. That will be what? 2x ln x plus x. So I can take x common factor. I have 2 ln x plus 1. This is f prime. So f prime equals 0. That implies I have x equals 0 or 2 ln x plus 1 equals 0. This does not belong to the domain of f. Domain of f is strictly greater than 0. This one, we just solve it. I have 2 ln x equal -1. So ln x equal -half. Take e. So x equal e is -half. In other words, is 1 over square root of e. Belongs to the domain? Yes. Belongs to the domain of f. So what are the critical numbers? By the way, f prime equal, not equal, does not exist. We have, actually, I have x to be greater than 0. Yeah. So I have the critical numbers are x equal 1 over square root of e, which is this. The number of critical number of this function. Okay, let me do the calculation. First, yeah, by the way, let me write it. This is what? X to the power 1 over 3 minus 1 over x to the power 2 over 3. This is the function. Just to check the domain. So what's the domain? X not equal to 0. Okay. Now, he wants the number of critical numbers. He doesn't want the critical numbers like in the previous ones, but he wants the number of critical numbers. How many we have? Yeah, let me do the calculation. Now, first I'll find f prime. That will be what? 1 over 3, x to the power minus 2 over 3. And this is plus 2 over 3, x to the power minus 5 over 3. Okay. So let me take a common factor. So common factor, take 1 over 3, x to the power minus 5 over 3. That give me what? X plus 2. X plus 2. Is it? Yeah, multiply. I have 2 over 3. And this one I have x to the power minus 3. Everything is okay. Yeah, so this is, I can rewrite it as x plus 2 over 3, x to the power 5 over 3. So f prime equal to 0. That implies x equal -2. Is it in the domain? Yes, belongs to the domain of f. F prime does not exist if x equals 0. But is it in the domain of f? No, it does not belong to the domain of f. So what are the critical numbers? X equal -2. How many are they? Only one. The critical numbers. You want the critical numbers of this function. What's the domain? Or real numbers. We have no restriction in this or that. Okay. So we'll find f prime. Product rule. Derivative of the first. That give me what? 1 plus 2x. Yeah. Times e minus x. Plus the first derivative of e minus x. So that will be minus e minus x. So I can take e minus x common factor. What's the remaining? 1 plus 2x minus 1 minus x squared. So I have what? This is cancelled. So I have x minus x squared over e to the power x. That will be f prime. So if prime equals 0, that implies I have x minus x squared, which is x times x minus 1 equals 0. So I have x equals 0 or x equals 1. This belongs to the domain of f? Yes. This belongs to the domain of f? Yes. So the domain of f ordinary numbers. Huh? F prime does not exist. E to the power x equals 0. This is impossible. Yeah, e to the power x, I know it's always positive. Okay. So what are the critical numbers? 0 and 1. That would be the answer. The sum of all critical numbers for this function. You want the sum of the critical numbers. Find them and then add them. This is the set of all critical numbers. This is how many critical numbers they have. So the set of all critical numbers, yeah. But all the questions is repeating itself. Find the critical number. I need to find the critical numbers. Okay, let me do the next one. Calculation. What's the domain of f? I need 4x plus 1 to be positive. So I need x to be greater than 1 minus 1 over 4. Okay, f prime. Careful the calculation. I have 2x times 4x plus 1 to the power minus the power of half. Yeah, so the derivative of the numerator times the denominator minus the derivative of this, which is half 4x plus 1 to the power minus half times 4. Don't forget this times the numerator. All over this one. Yeah. Is it? Yeah, this is the power half. That will be half 4x plus 1 to the power minus half times the derivative of the thing inside, which is 4. Okay, let me simplify it now. Let me take a common factor here. I will take 4x plus 1 to the power minus half as a common factor. What is the remaining? I have 2x times 4x plus 1, which now I have 2x multiplied to get this. Correct. Over square root. Over, no, not the square root. 4x plus 1, without the square root. Since I need the square of this. Well, that would not make an effect, but this is the correct one. Okay. Minus. If I took this as common factor, yeah, be careful. 4 with 2 cancel, they have 2. So I have minus 2x squared plus 14. Okay. That give me what? This is, I can take it to the denominator. So I have in the numerator what? 8x squared plus 2x minus 2x squared minus 18 over 4x plus 1 to the power 3 over 2. That give me what? 6x squared plus 2x. I can take 2 common factor. Yeah, this is 6. Huh? This is 6. I take 2. So I have 3x squared plus x minus 9 over this. B over A. Yeah. No, this is not 18. 28, sorry. This is 28. So this is 14. Yeah, makes sense now. Yeah. Okay. I need to factor this. Yeah. How to factor this one? I have 2. I have 3x. This is x. This is 14. So I need minus 2 and plus 7. Is it? 7x minus 6x. This is x. Correct. Over this one. Okay. So f prime equals 0. This is f prime, by the way. F prime equals 0 implies what? X equal minus 7 over 3. And or x equal 2. Is this one in the domain of f? This is the domain of f. X greater than minus 1 over 1. This does not belong to the domain of f. So it's out of, so it's not a critical number. X equal 2 is in the domain of f? Yes, in the domain of f. So this is a critical number. F prime does not exist. implies x equal minus 1 over 4. Does not belong to the domain of f. So what are the critical numbers? Actually, we have only one, which is x equal 2. So what is the sum? The sum of only one value, that will be 2. So this is the answer. He said the sum, but actually you have only one critical numbers. In the set of critical numbers to this function. What's the domain? First check the domain of f. So I need to solve this. Is it done equal to 0? So I need to put the numbers 0 and 8. Yeah. Take a value less than 0, minus 1. I have what? Negative, negative, that will be positive. Take a value like 1, it will be positive, negative, that will be negative. More than 4, more than 8, take 9, that will be positive. So what's the domain of f? From minus infinity to 0, union 8 to infinity. That will be the domain of f. Okay. Actually, if you look at the answer, you know the domain. This is out of the picture. This cannot be. This cannot be. This cannot be. It's not in the domain. This is cannot be. This cannot be. And this cannot be. So this is the only answer. But let us do the calculation. F prime of x. It will be what? Yeah. That will be 2 root x squared minus 8x. Okay. Derivative of this, which is what? 2x minus 8. So that will be x minus 4 over square root x squared minus 8x. F prime equals 0. So I have x equal 4. But this does not belong to the domain of f. F prime does not exist. That means I have x squared minus 8x equal to 0. So I have x equal 0 or x equal 8. This belongs to the domain of f since it's closed. And this belongs to the domain of f. So what is the set? What are the critical numbers? X equals 0 and x equal 8. So this will be the set. Yeah, you notice we have only I mean, when f prime does not exist. Huh? Okay, let me do. Yeah, let me do this one, then I will stop. Okay. Absolute value x squared minus 1. We have critical numbers. How to graph such function? Yeah, can graph it easily. I know how to graph x squared minus 1. This is what? Just a parabola. Just a parabola. At 0, it's minus 1. So it's just a parabola like this. That will be x squared minus 1. Now, to have the absolute value, the meaning of the absolute value means what? Means this negative side, I will make it positive. And the rest is the same. And the rest is the same. Okay. So, what are the critical numbers from the graph? For sure, I have here a critical number. Since I have a relative, I have this, and this one, f prime is equal to 0, which is, what is this value? This is minus 1, so this is 1. So, I have f prime at 1 equals 0. F prime at 1 is equal to 0, so of critical number, x equal 1. Okay. What about these values? This is minus 1, and this is 1. I mean, if prime at 0, huh? Not that. Yeah, at 0 is equal to 0. This is at 0. This is 0. Now, what about at, yeah, let me do it the other one. From the graph. From the graph, I need to check when f prime is equal to 0. F prime is equal to 0, if x equals 0. X equals 0. Is it in the domain of f? What's the domain of f, by the way? Or in numbers. We have no restriction. So this belongs to the domain of f. Yes, so it's a critical number. F prime does not exist. When if prime does not exist, I have the 1 and minus 1. So x equal minus 1, x equal 1. Is that in the domain of f? Yes. Is that in the domain of f? Yes. So how many critical numbers we have? We have 3 critical numbers. What are they? X equals 0, x equal minus 1, x equal 1. So we have 3 critical numbers from the graph. I think the easiest way to do it is through the graph. Now let me stop the recording. I don't like to have long videos, long recordings. So I will stop that now. Thank you.